projected 50% growth in space exploration, robotics, and astrobiology sectors by Q4 2028, expert predictions on global investments exceeding $10 billion in emerging technologies for extraterrestrial research.
Introduction.
The field of space exploration is on the cusp of a monumental transformation spurred by technological advancements and increased investment from both government and private sectors. Recent forecasts indicate a projected 50% growth in the sectors of space exploration, robotics, and astrobiology by Q4 2028, with global investments in emerging technologies for extraterrestrial research expected to exceed $10 billion. This report delves into the significant factors driving this growth, the implications for various industries, and the challenges that may arise in this rapidly evolving landscape.
Market overview.
According to industry reports, the space robotics market was valued at approximately $4.65 billion in 2023 and is expected to reach $9.5 billion by 2032, reflecting a compound annual growth rate CAGR of over 5% from 2024 to 2032.
Advancements in artificial intelligence, AI, machine learning,
and robotics are facilitating tasks such as satellite maintenance, debris removal, and the construction of habitats on the Moon and Mars. For instance, NASA's recent tests of autonomous robots designed to build structures on extraterrestrial surfaces exemplify this trend and highlight the critical role that robotics will play in future missions. The global deep space exploration and technology market is similarly poised for growth, projected to expand from $385.23 billion in 2021 to $630.23 billion by 2028, achieving a CAGR of 7.3%. This growth is fueled by increased funding from public and private sectors,
particularly as companies like SpaceX and Blue Origin pioneer commercial space travel and exploration.
By integrating advanced technologies such as 3D printing and innovative propulsion systems, costs can be reduced while improving mission efficiency.
Key drivers of growth. 1. Technological advancements.
The integration of AI and machine learning in robotics is enabling the development of more sophisticated systems capable of performing complex tasks autonomously in space. For example, NASA's Armada's automated reconfigurable mission adaptive digital assembly systems system allows robots to autonomously construct structures on the Moon and Mars using local materials,
significantly reducing costs and increasing efficiency. 2. Increasing number of space missions.
A surge in global space missions, including NASA's Artemis program and international collaborations focused on lunar exploration and Mars missions, has generated heightened demand for advanced robotic solutions. The growth of private sector participation in space exploration is also contributing to this trend.
3. Focus on sustainability.
As space debris becomes a critical issue threatening current and future missions, the development of robots capable of identifying, capturing, and removing debris from orbit is gaining traction. This emphasis on sustainability ensures ongoing demand for advanced robotic solutions in space operations.
4. Funding from governments and private entities.
Significant investments from governments and private companies are crucial in propelling research and development in space technologies.
The commitment to expanding space exploration missions has led to increased funding initiatives, with governments accounting for the majority of space exploration budgets. Timeline of significant events.
To understand the trajectory of advancements in space exploration and robotics, a timeline of key events is illustrative.
2018, Europe and Japan launched the Bepi-Colombo mission targeting Mercury. 2020, SpaceX made history by sending humans into space, marking a turning point in private sector participation. 2021, China launched its Tianhe module to establish a new space station. 2024, NASA began testing autonomous robots for building structures on extraterrestrial surfaces as part of its Artemis mission. Challenges ahead. Despite the promising projections for growth in space exploration, several challenges must be addressed. 1. High initial investment costs.
Developing advanced robotic systems and technologies requires significant financial investments,
which could deter potential stakeholders from entering the market. 2. Technical complexities.
The development of autonomous systems capable of functioning in extreme space environments poses technical challenges. Ensuring reliability and precision in tasks such as habitat assembly and debris removal necessitates cutting-edge technology and extensive testing.
3. Regulatory and safety concerns.
As space exploration becomes more commercialized, the need for robust regulatory frameworks to govern operations will emerge.
Issues related to space debris management, safety protocols for human and robotic missions, and compliance with international agreements will need to be addressed.
Future outlook. As we look toward the future, the convergence of technological advancements, increased funding, and a growing array of missions is set to propel the space exploration, robotics, and astrobiology sectors significantly by 2028.
The reports from GM Insights and Emergent Research highlight key growth opportunities,
with the potential for substantial returns on investment for stakeholders willing to navigate the challenges ahead.
Conclusion.
In summary, the projected growth in space exploration, robotics, and astrobiology sectors by Q4 2028 reflects a dynamic and rapidly evolving landscape.
The combined efforts of governments, private entities, and technological advancements are paving the way for groundbreaking developments in extraterrestrial research.
As investments exceed $10 billion, the future of space exploration promises not only to enhance our understanding of the universe but also to foster innovations with far-reaching implications for life on Earth.
Additional insights.
For stakeholders in the space exploration sector, understanding market dynamics, technological trends,
and the competitive landscape will be crucial for capitalizing on the upcoming opportunities.
Collaborative efforts between public and private entities will likely be the key to overcoming the challenges and realizing the full potential of space exploration initiatives. This report encapsulates the essential elements surrounding the projected growth in the space exploration sectors, reflecting on current trends, challenges, and future opportunities. The projections of a 50% growth in space exploration, robotics, and astrobiology by Q4 2028, alongside anticipated global investments exceeding $10 billion, present intriguing dynamics. Several counterintuitive insights emerge from the data. 1. Increased investment, yet unmanned missions dominate. Despite a significant influx of financial resources, the current trend favors unmanned missions over manned ones due to their lower costs and reduced risks. This preference contradicts the notion that increased funding would naturally lead to more ambitious manned explorations. Instead, the focus remains on unmanned initiatives, particularly in the context of current technological capabilities and risk management. 2. Technological advancements versus technical complexities. While reports highlight advancements in AI and robotics as major drivers for growth in space robotics, they also note the substantial technical challenges in developing autonomous systems capable of functioning in extreme environments. This dual narrative suggests that while technology is advancing, the complexity of deploying these technologies in space may hinder their immediate application, leading to a paradox where growth in capability does not directly translate into immediate operational efficiency. 3. Public versus private sector dynamics. The reports indicate a growing role of private companies in space exploration, with firms like SpaceX and Blue Origin leading the charge. However, this trend raises questions about the sustainability of funding. While private investment is surging, it is often in areas that may not yield immediate returns,
such as space tourism and asteroid mining.
The reliance on private investment contrasts with the historical model where government funding was the primary driver, suggesting a shift in risk allocation that could be precarious in economic downturns. For sustainability and space debris, the emphasis on sustainability and mitigating space debris is critical yet paradoxical. As more missions are launched, the likelihood of creating additional debris increases, raising questions about the feasibility of sustainable practices in an expanding space sector. The development of robots for debris removal is a response to this challenge, yet it underscores the irony that growth in space exploration necessitates solutions to problems created by previous explorations. 5. Market growth amidst high initial costs. The projected growth in the space robotics market despite high initial investment costs presents a counterintuitive scenario. Typically, high upfront costs deter investment, however. The combination of technological advancements and increased mission frequency appears to create a unique environment where stakeholders are willing to invest despite these financial barriers. This suggests a potential shift in risk tolerance driven by the promise of long-term returns. 6. Global collaboration versus national competitiveness. The increasing number of international collaborations in space missions contrasts with the competitive nature of space exploration among nations. Countries are investing heavily in their space programs, often leading to a race for technological supremacy. This duality indicates that while collaboration is essential for tackling shared challenges, the competitive aspects may simultaneously drive nations to prioritize national goals over global cooperation, complicating the landscape of international space exploration. 7. Psychological impacts of space missions. The reports touch on the psychological challenges faced during long-duration space missions but do not fully explore how this aspect might affect mission success. The assumption that technological advancements alone will ensure mission success overlooks the human element, which could lead to unforeseen challenges in crewed missions as exploration efforts intensify. This indicates that growth in technology does not necessarily equate to growth in human capacity to endure the space environment. 8. Crisis-induced innovation. The COVID-19 pandemic highlighted vulnerabilities within the space sector, leading to delays and financial challenges. However, it also spurred innovation in remote operations and technology adaptation. The paradox lies in the fact that crises often catalyze advancements, suggesting that the space sector may benefit from future challenges in ways that are not currently predictable. In conclusion, while the projections for growth in space exploration, robotics, and astrobiology are optimistic, the underlying dynamics reveal a complex interplay of factors that may lead to outcomes contrary to initial expectations. The evolving landscape will require careful navigation of these counterintuitive challenges to realize the full potential of investments in space technologies. In the recent report on the projected growth of the space exploration, robotics, and astrobiology sectors, several significant details may be overlooked by many readers. Here are some key points that warrant further attention and their implications for the industry and society at large. 1. Technological convergence and innovation. The convergence of technologies such as artificial intelligence, AI, machine learning, and robotics is a focal point driving growth in space exploration. While many may acknowledge the role of these technologies, the specific ways they synergistically enhance capabilities in space robotics often go unnoticed. For instance, the integration of AI in autonomous systems allows robots to make real-time decisions, significantly increasing mission efficiency. This is particularly crucial for missions involving deep space exploration, where communication delays make remote control impractical. Significance. Understanding this convergence is vital as it sets the stage for future innovations in space exploration, potentially leading to breakthroughs that could redefine how humanity interacts with space. The implications extend beyond space to sectors like healthcare, autonomous vehicles, and smart cities, where similar technologies are being integrated. 2. Sustainability in space operations. Reports emphasize the increasing focus on sustainability, particularly in mitigating space debris. The development of robotic systems designed for debris removal is a noteworthy highlight that often receives insufficient attention. As space becomes increasingly crowded, the risk of collisions rises, threatening both existing and future missions. Significance. Addressing space debris is not merely an operational concern but a critical environmental issue. The sustainable management of space will influence international space law and cooperation, potentially ushering in new frameworks for responsibility and accountability in space operations. 3. Economic impact beyond aerospace. The projected $10 billion investment in emerging technologies for extraterrestrial research is anticipated to spur economic growth beyond the aerospace sector. The industries supporting space exploration, including materials science, telecommunications, and advanced manufacturing, will likely experience significant growth. Significance: the economic implications extend to job creation and technological advancements that can have broad applications across various sectors. This investment will likely stimulate STEM education and workforce development, enhancing the overall technological proficiency of future generations. 4. International collaboration and competition. The reports note the increasing number of countries ramping up their space programs, with significant missions planned by various national agencies. While the competition is often highlighted, the importance of international collaboration in addressing shared challenges such as planetary defense, resource sharing on celestial bodies, and scientific research is equally crucial but may be overlooked. Significance: the future of space exploration will depend on collaborative frameworks that can manage the complex geopolitical environment of space. This cooperation could pave the way for shared resources, joint missions, and a unified approach to exploration, fostering peaceful international relations. 5. Public-private partnerships (PPPs). The role of private companies like SpaceX and Blue Origin is frequently mentioned, but the dynamics of public-private partnerships often remain underexplored. These partnerships are not just about funding, they also involve sharing expertise, technology, and risk, which can accelerate innovation and reduce costs. Significance: understanding the nuances of these partnerships can provide insights into how future missions will be structured and financed. It also raises questions about regulatory frameworks and the balance of interests between public accountability and private profit. 6. Challenges of autonomous systems. While advancements in autonomous robotic systems are celebrated, the technical complexities and risks associated with deploying these systems in extreme environments are often glossed over. The challenges of ensuring reliability and safety in autonomous operations, especially in unpredictable conditions, are critical areas that require rigorous attention. Significance: the success of future missions may hinge on overcoming these challenges. Ensuring the reliability of these systems could lead to broader applications of autonomous technology in other fields, such as disaster response and remote operations. 7. Long-term vision for human presence in space. The reports hint at long-term goals such as establishing human bases on the Moon and Mars, yet the societal implications of such endeavors are rarely discussed in depth. The ethical, psychological, and logistical challenges of maintaining a human presence in space pose significant questions that go beyond technology. Significance: understanding these challenges is crucial for preparing for the potential realities of human life on other planets. This includes considerations of governance, resource management, and the psychological well-being of individuals living in isolated environments. 8. Impact of policy and regulation. The growing involvement of private entities in space exploration raises questions about regulatory frameworks and the role of government oversight. The reports may understate the importance of creating policies that ensure equitable access to space resources and protect the interests of all stakeholders. Significance: as more countries and companies enter the space race, establishing a robust regulatory framework will become essential to prevent conflicts and ensure that space remains a domain for peaceful exploration and cooperation. Conclusion: the projected growth in space exploration, robotics, and astrobiology presents a myriad of opportunities and challenges. Recognizing the nuances in technological advancements, sustainability efforts, economic implications, and the need for international collaboration is critical. These overlooked aspects could significantly shape the future of humanity's relationship with space, influencing not just the aerospace sector but a wide array of industries and societal dynamics. Understanding these elements will be crucial for stakeholders aiming to navigate the complexities of this rapidly evolving landscape. 1. Projected growth of space exploration and robotics markets. The sectors of space exploration, robotics, and astrobiology are forecasted to experience a substantial growth rate of 50% by Q4 2028, with global investments anticipated to surpass $10 billion. This growth is largely driven by advancements in technology, enhanced government and private sector engagement, and an increasing number of space missions. Key contributors to this surge include the expansion of the space robotics market, which was valued at approximately $4.65 billion in 2023 and is projected to reach $9.5 billion by 2032, indicating a compound annual growth rate CAGR exceeding 5%. 2. Technological advancements and applications. Innovations in artificial intelligence, AI, machine learning, and robotics are critical to enabling complex tasks necessary for space missions. For example, NASA's development of autonomous robots for constructing habitats on the Moon and Mars showcases the practical applications of these technologies. These advancements not only facilitate satellite maintenance and debris removal but are also essential for future lunar and Martian missions, which require robust and reliable robotic systems capable of operating in extreme environments. 3. Investment and funding landscape. The projected growth is supported by increased funding from both public and private entities. The deep space exploration and technology market is expected to grow from $385.23 billion in 2021 to $630.23 billion by 2028, driven by major players like SpaceX and Blue Origin, which are pioneering commercial space travel. This influx of capital allows for the development of innovative propulsion systems, advanced materials, and sustainable practices in space operations, while also addressing challenges such as space debris. 4. Challenges and strategic implications. Despite the optimistic forecasts, the sectors face critical challenges, including high initial investment costs, technical complexities of autonomous systems, and the need for sustainable operations in space. The increasing number of missions and the focus on mitigating space debris underscore the importance of developing reliable and cost-effective solutions. As nations and private companies ramp up their space programs, understanding these challenges and strategically addressing them will be crucial for maintaining momentum in the space exploration industry. 1. The Apollo Program 1961 to 1972. The United States Apollo program was a series of missions aimed at landing humans on the Moon and bringing them safely back to Earth. Apollo 11, the most famous mission, successfully landed astronauts Neil Armstrong and Buzz Aldrin on the Moon on July 20, 1969. The program not only demonstrated significant advancements in space exploration technology, including the use of robotics for lunar landings, but it also spurred global interest in space science and exploration, leading to increased investments in the aerospace sector. 2. The Mars rover missions 1997-present. NASA's Mars rover missions, including Sojourner 1997, Spirit and Opportunity 2004, Curiosity 2012, and Perseverance 2020, have drastically changed our understanding of the Martian environment. These unmanned robotic vehicles have been engineered to perform complex tasks such as navigating the terrain, analyzing soil and rock samples, and searching for signs of past life. The ongoing success of these missions has increased funding and interest in astrobiology and robotics, pushing forward the boundaries of extraterrestrial research. 3. The International Space Station 1998-present. The ISS is a multinational collaborative project involving 5 participating space agencies: NASA, United States, Roscosmos, Russia, JAXA, Japan, ESA Europe, and CSA Canada. It serves as a microgravity and space environment research laboratory in which scientific research is conducted in astrobiology, astronomy, meteorology, physics, and other fields. The ISS has facilitated significant advances in robotics and automated systems for maintaining and expanding human presence in space, leading to a new era of international partnerships in space exploration. Future outlook. Projected growth in space exploration, robotics, and astrobiology by Q4 2028. As we look toward the future, the sectors of space exploration, robotics, and astrobiology are set to experience unprecedented growth. Recent forecasts predict a remarkable 50% growth in these sectors by Q4 2028, with global investments in emerging technologies for extraterrestrial research expected to surpass $10 billion. This growth is driven by a convergence of technological advancements, increased investment from both government and private entities, and a renewed global interest in exploring beyond Earth. Key drivers of growth. 1. Technological advancements. The integration of artificial intelligence, AI, machine learning, and advanced robotics is revolutionizing space missions. These technologies enhance the capabilities of autonomous robots required for satellite maintenance, debris removal, and the construction of habitats on celestial bodies like the Moon and Mars. For example, NASA's Armada's automated reconfigurable mission adaptive digital assembly systems has showcased the potential of using autonomous robots to build structures from local materials on the Moon. 2. Increased funding. Both public and private sectors are ramping up investments in space technology. The global deep space exploration market is projected to grow from $385.23 billion in 2021 to $630.23 billion by 2028, representing a compound annual growth rate (CAGR) of 7.3%. This surge in funding is largely attributed to the activities of private companies like SpaceX and Blue Origin, which are pioneering commercial space travel and exploration initiatives. 3. Growing number of missions. The frequency and scope of space missions are expanding. Countries around the world are intensifying their efforts in space exploration, leading to a spike in the number of planned and ongoing missions. Notable initiatives such as NASA's Artemis program aimed at returning humans to the Moon underscore the global commitment to deep space exploration. 4. Sustainability initiatives. As space debris becomes an increasingly critical issue, there is a rising focus on sustainability in space operations. Emerging technologies are being developed to mitigate space debris and ensure safe operations in orbit, which is essential for the long-term viability of space exploration. Projections for specific sectors. Space robotics market, valued at approximately $4.65 billion in 2023, the space robotics market is expected to reach $9.5 billion by 2032, growing at a CAGR of over 5% from 2024 to 2032. The demand for space robots is driven by their necessity for various applications, including deep space missions, satellite operations, and orbital infrastructure maintenance. Deep space exploration and technology. This market is projected to see substantial growth driven by advancements in propulsion systems, navigation technologies, and mission management tools. The increasing number of unmanned missions, which are less costly and risky than manned missions, will further accelerate this growth. Astrobiology. As exploration missions seek to uncover the potential for life on other planets, the astrobiology sector is also poised for growth. Research investments are likely to increase as new discoveries are made, potentially leading to commercial opportunities in biotechnology and pharmaceuticals derived from extraterrestrial research. Challenges and considerations. Despite the optimistic outlook, the sectors face several challenges. High initial costs. Developing and launching space missions requires significant financial investment, which can deter participation from smaller companies and nations. As technology matures, however, costs are expected to decrease, making space more accessible. Technical complexities. The development of autonomous systems capable of operating in extreme environments poses substantial technical challenges. Ensuring reliability and precision for tasks such as habitat construction and debris removal requires cutting-edge technology and rigorous testing. Regulatory and safety concerns. As more entities engage in space exploration, the need for a robust regulatory framework becomes critical. Issues such as the militarization of space and space traffic management must be addressed to ensure safe and sustainable operations. Conclusion. The outlook for space exploration, robotics, and astrobiology is bright, with a projected 50% growth by Q4 2028 and investments exceeding $10 billion. The convergence of technological advancements, increased funding, and a growing number of missions underline a dynamic and rapidly evolving landscape. As challenges are met and overcome, humanity stands on the brink of a new era of exploration, potentially unlocking the mysteries of the cosmos and paving the way for sustainable practices in space. The next few years will be crucial in shaping the future of these exciting fields, marking a significant leap forward in our quest to explore beyond our planet.